So in this problem, we need to verify the following. Let us begin from the left hand side of the problem. So here we have sine x minus sine 3x divided by sine squared x minus cosine squared x. So if we multiply both numerator and the denominator with -1, we get sine 3x minus sine x whole divided by cosine squared x minus sine squared x. Now the reason why we multiply both numerator and the denominator with -1, because we wanted to make the magnitude of 3x greater than the magnitude of x, provided x is greater than 1, because this will be easier for us to apply the formula. If we have, let's say, sine of angle A minus sine of angle B, that will be given by 2 times cosine of angle A plus B over 2 multiplied to sine of angle A minus B over 2. This will be equals to, so we have 2 times cosine of angle 3x plus x divided by 2 multiplied to sine of angle 3x minus x over 2 whole divided by, now we have cosine squared x minus sine squared x. Now we know there's a formula for cosine 2x, so cosine 2x expands to give us cosine squared x minus sine squared x. So we have cosine of 2x in the denominator. So let's further simplify. Now we have 2 times the cosine of 3x plus x over 2, that's going to give us cosine of 2x. And sine 3x minus x over 2 will be sine simply x whole divided by cosine of 2x. So cosine 2x gets cancelled out. Now we are left with 2 times sine x, and this is going to be the expression on the right hand side. So therefore, we have successfully showed that the left hand side of the trigonometric equation is equals to the right hand side, hence proved.